Something stirred beneath Mount Rainier, and it didn't go unnoticed. Hundreds of tiny quakes, like a warning whispered through stone. No lava, no smoke, just silence, and the uneasy sense that time might be running out. So what does it mean when the ground won't stop shaking? What just happened? In July 2025, Mount Rainier experienced a swarm of over 350 small earthquakes, the largest monthly total ever recorded at the Volcano. Most of these quakes were shallow, occurring 2 to 4 kilometers, about 1 to 2.5 miles, beneath the surface, directly under the summit and upper flanks. The swarm wasn't violent. Magnitudes were mostly between 1.0 and 2.5, but it was the frequency and clustering that caught scientists' attention. Some quakes came just minutes apart. This pattern suggests that something beneath the mountain may be shifting, such as pressurized fluids or gases moving through underground cracks. While Rainier has had earthquake swarms before, including notable ones in 2009, 2016, and 2021, this one is more intense, more concentrated, and longer lasting. Scientists aren't saying an eruption is imminent, but this level of activity could indicate changes in the hydrothermal or magmatic systems, both of which are warning signs for potential hazards. Combined with the volcano's icy slopes and lahar history, it's a reminder that Rainier doesn't have to erupt to cause disaster. Rainier, the real threat. Mount Rainier tops the threat list, not because it erupts often, it tops it because of what happens if it does. The U.S. Geological Survey ranks Rainier among the most dangerous volcanoes in America, not for frequency, but for impact potential. Over 3 million people live in the Seattle-Tacoma metro area, with tens of thousands in the river valleys that flow from Rainier's flanks, the exact areas most at risk. The real danger isn't lava, it's lahars. Lahars, fast-moving volcanic mud flows triggered by heat or collapse. Rainier is capped with over 25 major glaciers, more ice than any other U.S. volcano. If even a small eruption or flank failure occurred, it could melt that ice rapidly, sending torrents of rock, water, and debris rushing downhill at freeway speeds. And Rainier's steep, unstable slopes make those collapses more likely. Even without an eruption, entire communities in the Puyallup and Carbon River valleys sit on top of ancient lahar deposits. These flows have happened before, and they'll happen again. The only question is when. When fire meets ice. Here's how lahars happen. When magma rises, or even when part of the slope collapses, that heat rapidly melts the ice, unleashing torrents of mud and debris. That's what's called lahars. This has happened before, on a massive scale. About 500 years ago, the electron mudflow thundered down Rainier's western flank, burying parts of the Puyallup Valley under 30 feet of debris. Around 5,600 years ago, the Osceola lahar surged over 100 square miles, reaching as far as modern-day Auburn and Kent. Scientists estimate it moved at speeds up to 40 miles per hour, carrying boulders the size of cars. Lahars follow river valleys like the Puyallup, Carbon, and White, areas now lined with homes, schools, and highways. With no fireballs or lava to warn them, communities in these valleys could have less than an hour to evacuate once a lahar begins. When volcanic heat meets ice, the result is cold, fast, and often fatal. Is this magma movement? The July 2025 quake swarm beneath Mount Rainier has raised the big question: is magma on the move? According to USGS volcanologists, most of the quakes occurred 2 to 4 kilometers beneath the surface, shallower than usual, but not definitive proof of magma intrusion. So far, the pattern appears tectonic, likely due to minor stress shifts in the crust. Rather than molten rock rising, magma intrusion swarms tend to produce harmonic tremor, a rhythmic seismic signal, along with ground deformation, gas emissions, or heat anomalies. None of those signs have been detected at Rainier. In contrast, tectonic swarms are shorter, sharper, and lack those secondary indicators. Still, scientists are watching closely. A USGS statement released July 27th noted, "While current activity does not indicate an imminent eruption, the unusual intensity and location of these quakes make continued monitoring essential." In short, this isn't magma yet, but the deeper the swarm, the more attention it gets, especially when it hits a volcano with Rainier's deadly history. One shift in seismic pattern could change the outlook fast. How we're watching it. Mount Rainier is under constant watch, both from the ground and from space. More than 20 seismometers, GPS stations, and tilt meters surround the mountain, feeding real-time data to the USGS and the Pacific Northwest Seismic Network. These instruments detect even the tiniest shifts in the Earth's crust, helping scientists spot early signs of magma movement or glacial destabilization. Above, satellites track ground deformation using INSAR, interferometric synthetic aperture radar, capable of measuring surface changes as small as a few millimeters. These satellite passes are vital for spotting bulges or subsidence that might hint at magma intrusion. Should things escalate, the U.S. has early warning systems like the Volcano Notification Service, which alerts emergency managers, airlines, and the public within minutes. Local counties also maintain lahar warning systems, including sirens and automated texts, giving valley communities a fighting chance to evacuate if the mountain ever truly wakes up. What if it blows? If Mount Rainier erupts, residents in towns like Ording might have as little as 40 minutes to evacuate. That's why sirens are installed, but time is tight. FEMA hazard maps show that lahars could engulf communities along the Puyallup River Valley, including parts of Puyallup, Sumner, and Tacoma's port area. Over 150,000 people live in these lahar zones. The damage wouldn't stop at homes. Key infrastructure is directly in harm's way. Bridges, Interstate 5, portions of the railway network, and even Seattle's water supply, which relies on rivers fed by Mount Rainier's glaciers. In short, an eruption could sever transport, cripple utilities, and overwhelm emergency services, even if the blast itself is small. Has the clock started? While most quake swarms at Rainier fade without consequence, the July 2025 activity is different. The number of quakes could suggest a new phase of unrest, one that may signal magma slowly intruding beneath the volcano. USGS scientists stress that this isn't a sign of imminent eruption, but it does demand close attention. So scientists are watching more closely than ever, because for Rainier, timing is everything. A silent giant can become a violent one without much warning. The systems are in place: sensors, sirens, evacuation plans. But even the best laid plans are tested when minutes matter.